All right. When you're given problems like this, it really is to your advantage to just sketch them out. So I'm going to get my line drawing tool here, and I'm just going to sketch it out, and then I'm going to adjust it a little bit just because it's nice when my triangles connect. Okay, good enough. Okay, and then let's label it. We're going to label it with, let's see, R, Q, and S. It doesn't matter where they go as long as you put the measures in correctly. Measure of angle R is 38. The length of QR is 11. And the length of RS is 16. What we're looking for is the length of QS, which we can call X. Okay? And this is a situation, this is what law of cosines will be dealing with. Law of sine said two sides, two angles. Law of cosines is only one angle and then all three sides. Okay? And essentially what you're getting is the formula, I'm going to put it up top, is here. If you want to find that side length that's opposite from the angle, you say that's equal to the square root of, the square root of, and then we take the two sides that we know. (11) squared plus 16 squared. You take the two sides that you know, essentially the sides that are both adjacent to 38, and you do kind of like a squared plus b squared, right? You do those two sides squared. Then minus 2 times one of those sides that they had times the other side that they had times the cosine of, and then the angle that they had, which is 38. And I think that I ran out of room, so just a second. Okay, cosine of 38. Yeah, so you can actually calculate all of this in your calculator. If you have a TI-84, you can just type it straight across. We can do this in pieces if you wanted to see what it looks like. Square root of, you can calculate it all out. 11 squared, 121. 16 squared, gosh, isn't that 256? 16 squared, 256. Minus 2 times 11 times 16. I can actually do this in my head. I can tell you why. I can do 2 times 16 is 32. And if any of you have been paying attention to me, if you multiply anything by 11, you take that thing, like 32, you split the digits apart, and you add them together for the middle number. There you go, 352 times cosine of 38. And instead of writing cosine of 38, I'm going to calculate it as cosine of 38. And the calculator says it's roughly equal to 0.788, because the next digit is 0 and then 1 and then 0 again. So that's pretty close, although typing it into the calculator is going to be your way of getting it most exact. And let's simplify these. Okay, we say x is equal to 121 plus 256 is 377 minus, and then we're going to do 352 times 0.788, and you get 277.376. And then if you further calculated that, we would say 377 minus 277.376, 99.6 624. You can see it's roughly 100, just under 100, so the answer should be just under 10 when you square root it. And you say x equals roughly, approximately equal to, and actually, where should I start writing approximately equal to? Well, as soon as I take something that's not an exact amount, that's when I should start doing it. So I should say here, when I rounded off cosine of 38 to 0.788, that's when I started getting approximate values. Okay, approximately equal to, and then I'll do the square root of that number. Second square root of that equals 9.98. And it says to the nearest tenth. What's the length of that? So I'm rounding to there. I say, is that 5 or higher? Yes, it is. And since it is, we say this 9 goes up to a 10, but that just puts a 0 there in the tenths place. Carry the 1, and 9 plus 1 is 10. Do you need to show 10.0, or can you write 10? You do need to show 10.0. You do need to. And the reason for that is that it asks you to show it out to the tenths place. So if there's a 0 in the tenths place, you need to show that it's a 0 there. Otherwise, it's not clear when you write 10. It's not clear that you rounded it to the correct place. Okay, that's it. Now, did you need to do all that? No. Well, no, in this sense. You could have taken, I'm going to do a screen grab of this the best that I can. Okay, you could have taken all of that, erase all that extra stuff out of there, and you could have just typed that into the calculator. You could have typed square root of 11 squared plus 16 squared minus 2 times 11 times 16 times cosine of 38, and hit equals. Just make sure you put the root in first around it all, and it would have immediately jumped you to the 9.98 whatever. Okay, so that's what I'm going to suggest. I'm going to suggest that you have your calculator and you type it in right from this point. And the calculator will do all that work for you. Okay, so we're going to do that moving forward for the next three. Okay, so we're going to do the same thing. What I was suggesting earlier is that you do your line drawing tool and you make some triangle that you can drop values into so that you have a visual representation of the situation. It just makes it, I think it just makes it a little bit easier. Okay. Good enough. Okay. Let's label it. Let's label it. We've got a W, an X, and a Y. And WX they give as a measure 20.4. Actually, I'm going to use a different color just for the values that we've got. 20.4. XY 16.4. And WY 25.3. Okay, what's the measure of angle W? Now, this is where these start to get tricky. Got to trust me on this. It's tricky because what's going on here, and I'm going to actually, screen grab all of this and copy it so that it stays labeled and together. Sorry that you're seeing kind of all of the thing that I'm doing here, but and let's get that out of there. Okay, so we're gonna have this, and here's the idea. I just want to move this over to the side from where I put it to give us more space to work, because when we write this out, you will need to be doing an inverse operation, and we're going to do all the math to calculate it. This one you're going to have to kind of just do the math on. Watch how you do it. Okay, so the general formula is this. I'm just going to write the formula out. You'll be given this, okay? You could say c squared equals a squared plus b squared minus 2ab cosine c. Yeah? Okay, so we're going to actually just use that formula and drop the values in. Then we'll eventually, once we got numbers in for everything except cosine c, or in this case cosine w, we will, juggle it around and solve it out to find out what that is. And we're going to have to do an inverse of cosine. But how do you know what the c value is? Well, it's opposite from the angle c. And really, angle c is just a general way of saying the angle you have or are looking for. So we're looking for w. So what's the opposite side from w? It is 16.4. So we're going to write in then 16.4 squared equals, and then the other two sides are a and b, it doesn't matter, okay? 20 squared, or sorry, 20.4 squared plus 25.3 squared minus 2 times 20.4 times 25.3 times cosine, in this case, w. And we can come up with numbers for all these by using our calculator. And really, this is going to be, I think this is going to be the best way to do it. So we do 16.4 squared, and we get 268.96 equals 20.4 squared is 416.16 plus 25.3 squared, 640.09 minus, and now I'm just going to do 2 times 20.4 times 25.3 equals 1032.24 times cosine of w. Okay? And then we're going to start to simplify. The first thing we're going to do when we simplify is we're just going to keep this the same on that side, 268.96 equals, and we're going to add these first two numbers together, 416.16 plus 640.09 equals 1056.25. Now you will be tempted to subtract 1032.24 from it. Terrible idea. Okay, because that doesn't say 1032.24 all by itself. It says 1032.24 times the cosine of w, and you can't just forget that that's there and pretend like it's just a constant. So we continue right, minus 1032.24 cosine w, and then we're going to subtract away this amount that's in the front from both sides, minus 1056.25, okay, equals, so we say 268.96 minus 1056.25 equals, what do we get on that side? We get negative 787.29. You're going to get a negative number there, okay? I'll show you why in a second. And then what are we left with on this side? We're left with this remaining amount right here, negative 1032.24 times cosine w. So we say minus 1032.24 cosine w. And then, how do we get cosine w all by itself? We divide both sides by the number in front of it. So we get negative 787.29 divided by negative 1032.24 equals And when we divide this right-hand side by negative 1032.24, that just becomes a 1, right? So we just get equals cosine W. Now, you can see, hopefully, that the negative and the negative cancel out, making positives, right? So now you've just got the number, the simplified number of two positives, just like two negatives makes positive, two positives, right? Now is where we got to find W. And how do we do it? Now that we have just a single ratio over here of this over this, we can type, you don't need to calculate it to a number, and I suggest that you don't, because then you'll just be typing it again and taking that number, and you don't need to do that. What you need to do is you need to say now inverse cosine of, and type the ratio. Even if you didn't drop the negatives, as long as you had the negative on both of them, it would drop it for you. It would know what you're talking about, and it would make that positive. So don't worry if you didn't drop the negatives and you left them on there. In fact, maybe we should just put them back on just in case you didn't realize to cancel them out and you left them on, just to show that it doesn't actually really matter. Okay, those will make a positive. And then that will equal what W equals. So I'm going to then type second, and then hit the cosine button, and I'll get the inverse cosine, and I will type negative. The negative button, by the way, is just on the bottom to the left of the enter button. It's different than typing minus, and you should use the negative button. Got to trust me on this. Get used to using the negative button. Negative 787.29 divided by negative 1032.24, close parentheses, equals, and we get W. By the way, this should have been approximately equal to, oops, how far up? No, I guess it was still equal there. We didn't put in a rounded number there. Still equal there, because those decimal numbers were exact from doing those others. Okay, so here's where it becomes an approximation, because what we're going to get is 40.29, and it's saying, look up top, saying to the nearest tenth. So we're going to round off to the nearest tenth, and we're going to say W is approximately equal to 40.3 is what it is. Wow. Okay, so that seemed like a lot of huge calculations. So let's just really quickly review. You take this thing that you're going to get, which is c squared equals a squared plus b squared minus 2ab cosine c, and you're going to drop in all the numbers. How do you know where the numbers come from? Whatever, remember, this is where you are looking for an angle that you don't know. So you're going to use this, and you say the c value is going to be opposite the angle that you're looking for. Okay, so that number squared equals this number squared plus this number squared minus 2 times this times cosine of this. That's what all of that says. And then you start calculating and simplifying. Make sure that you're accurate in your numbers and you write everything down. Once you calculate all of those by squaring them and multiplying these three numbers together, make sure that stays negative, you combine these two, and then that amount that you got there, you subtract from both sides. So what you're left with is just this piece, that negative something cosine of the angle. Okay, and you're gonna get a negative number there, and then when you divide by another negative number, it's going to be positive. Okay. Yeah. So then you find out what this ratio is equal to the cosine of W, and you take that ratio and you do the inverse of that ratio to find the angle. Yeah, seems like a lot, but don't worry, we'll do more. All right, let's do this one. They're finding a side length, so this is going to be I'm going to keep using the c squared equals a squared minus a squared plus b squared. I'll write it out. Okay. Let's first draw a little bit of a diagram here. What are we talking about? Okay. Well, oops. If we just redraw that so that it's got that better. Okay. If we label this with the names of the angles, and we've got J, K, and L, okay, then JK is, I'll put these in a different color, JK is 2.6, KL is 6.4, and the measure of angle K, that included angle in between, is 10.5 degrees. Okay, to the nearest tenth, what is JL, this other side, which we will call X? Okay, so if we had the general formula, and I will write it out here, typically, like you'll see it as c squared equals a squared plus b squared, just like a squared plus b squared equals c squared. That first part's the same, but then because it's not a 90-degree angle, you have to add this additional minus 2ab, the two sides that you're using on this side anyway, right? You use them again. Cosine, and then the angle that is opposite, small side C, big angle C. That's the standard thing, right? Now we'll plug it in. Let's plug it in. All the numbers that we know. Remember, the c squared value is going to be whatever is across from the angle we've got. And what's across from the angle that we've got? It's that value we're looking for. Great. So don't forget that I didn't put a square root around everything, so we're now saying x squared, that side squared, equals the other two sides squared, 2.6 squared, plus 6.4 squared, minus 2 times 2.6 times 6.4 times cosine of, and what's the angle? Cosine of 10.5. Okay? And we know all of this information. Everything on the right-hand side is all numbers that we've either got or the calculator can calculate for us, which is like the cosine of 10.5. Okay? So I'm going to say x squared equals, and then I'm just going to type that whole thing into the calculator right now. I'm going to say 2.6 squared plus 6.4 squared minus 2 times 2.6 times 6.4 times the cosine of 10.5, close parentheses, equals, and I get the number, I'm going to have to write it as an approximate, but I get the numbers, and I'm going to write out the whole string of numbers. We're not rounding it until we actually do the square root. 14.99727,668. It's still rounded off. The calculator can only show it to a certain number of digits. And then we got to square root both sides. So we say the square root of x squared is, it's going to be approximately equal to the square root of this number, because the number is not an exact number of what it really should be. And then we get then that x is going to be approximately equal to the square root of that number, 3.87, because now is where we're going to round it to the nearest tenth. So we say that's the tenth place. Is this at least half of another tenth? Yeah, it's 5 or higher, so it is at least half of another tenth. So we round that up to saying that means that x is approximately equal to the 8 does change into a 9. Right? It's a lot easier when you're finding the side length than when you're finding the angle. That gets more complicated. But that's it, law of cosines. Now, remember, earlier I had just put C is equal to the square root of all of that. Essentially, if I calculated all of this first and then square rooted it, that's the same as if I put it all in there under the square root. Okay? But the reason that I wrote it out this way is because, and I'll get rid of that if I can. Oh, doesn't want to let me, but the reason that I wrote it out like this is because you can use that formula, this formula right here, for whether you're finding an angle or whether you're finding a side, because you'll have to unwrap this. So I'll just stick with this. And we got one more to do. Okay. Last one to do in this. And as before, I'm going to suggest that you draw the triangle out. Just draw some triangle out and you label it. Okay. The drawing itself doesn't need to be too accurate. It's fine. Because remember, we're just, not that we're meatballing it. That's not what I'm suggesting. But we are, our diagrams are not to scale, so it's okay if things don't look perfect. What we've got to do is drop the right numbers in. So what numbers do we drop in? We're going to say if triangle is DEF, and any of the 3 vertices can be D and E and F, then DE is 13, EF is 24, FD is 27, and what we're looking for is the measure of angle E. Okay? Well then, what do we have to write? We have to write the general formula of C squared equals A squared plus B squared minus 2AB cosine C. And what is that C length that we're going to use, C squared on the left-hand side? It's going to be whatever is opposite the angle that we are using, that we're trying to find in this case. Okay, so that's the opposite side, so we're going to say 27 squared is equal to, the other 2 sides are A and B, doesn't matter. 13 squared plus 24 squared minus 2 times 13 times 24 cosine C. Okay? Then we're going to start calculating the numbers themselves. We're going to actually calculate what is 27 squared. 27 squared on my calculator is 729 equals, what is 13 squared? 169. What is 24 squared? 576. And what is negative 2 times 13 times 24? You get negative 624 times cosine C. Okay? What we can combine at this point, and hopefully you will practice these enough to be able to get this in your brain, is we can combine these two. They are free. They are not attached to something else like this negative 624. It's attached to cosine C. It's essentially the coefficient of it. It's saying how many times do we take that value. Okay, so we can't just use it as its own constant number. So we can combine those two numbers, though. We can say 169 plus 576 is 745. So you say 745 minus 624 cosine C. And actually, I'm saying cosine C, but let me go back and change this. And let me actually write the cosine of E, because that's the angle that we're doing now that we've got the numbers. Okay? So I'm going to erase those numbers that we've got, or those calling it cosine C. And once we actually drop values in, we want to call that the cosine of angle E in that case. Okay. All right. Now, what are we doing here? We're going to subtract 745 from both sides. Because what we're doing is we're undoing everything that's happening to cosine E in order to isolate it. So we can do 729 minus 745, and we get negative 16 on this side. Negative 16 equals negative 624 cosine E, and then we need to divide both sides by negative 624. Negative 16 over negative 624 equals all of that divided by negative 624, right? And if you dropped those negatives, you get 16 over 624 equals cosine E. And then we can say then, okay, well then the inverse cosine of the ratio we found, 16 over 624, will give us angle E. Let's type that into our calculator. I've run out of room here, so I'm going to have to write it over here on the side. Okay, but inverse cosine of 16 divided by 624, and we get 88.53 something something. So I'm going to box this out over here and say, oops. Sorry about that. Glitching program. I'm going to box this section out over here just to give us space to write the rest of this, and we will get then 88.53 is approximately equal to the angle E. And since we're rounding, we're going to say we're rounding to the tenths place. We look one more. Is that 5 or higher? Nope, it's not 5 or higher. So we don't go up from the 5. We just keep it as 88.5 is approximately equal to E. And it's 88.5 what? It's 88.5 degrees because we were finding an angle. And we box that out as our answer. Okay. So start with the formula that you're going to be given. You will be given this formula up here. And you need to know that this value here, that C value, is the side opposite the angle that you've got or that you're trying to find. And these two are the other two triangle sides. So that squared equals that squared plus that squared minus 2 times that times the cosine of that angle. And then plug in the numbers and simplify it out. Square everything, multiply these together. Combine these two into a single number and subtract that number from both sides. Then you get this equals something times the cosine of E, divide both sides by that number, drop the two negatives, there's two negatives, and then from this ratio you can do the inverse cosine of that ratio and it'll tell you the angle. Cool.